Okay, we retain another integral. This one's from the Swinbee 2023, problem 9. We have the integral of 1 over 1 minus tan squared x dx. Okay, to get started with this, what I want to do is this common trick of multiplying by 1, just multiplying by secant squared x over secant squared x. And when I do this, I want to multiply in the secant squared x, trying to set up a u substitution, because the integral of tangent is going to be secant squared, so that part's going to work nice. But what I want to do on this other secant squared x, let's just use a trig identity on this and write this as 1 plus tan squared x. So when we write this all out, we're going to have the secant squared here in the numerator, and then the denominator is just going to become 1 minus tan squared x, and then we have this part, which is 1 plus tan squared x. And now that we have tangent here and here in the denominator, let's just do a u substitution on this. I'm going to set u equal to tan of x, take a derivative, and we have du is going to be secant squared x dx. So when we substitute this, the whole numerator is going to become this du value, and then this is going to become 1 minus u squared, 1 plus u squared. And the last time I came across something like this, I did out the partial fractions the long way. You can do that, it's fine. But you know, people seem to like it better if you take a shortcut, so let's take a shortcut on this one. What you can do with these in a lot of cases is just kind of create some cancellation. So what I'll do is, let's just kind of create a 1 plus u squared, knowing that that's going to cancel with this. And what I can do is add it to this right here, 1 minus u squared, because that'll cancel here. Now there is one problem. When you add up the numerator, you'll find the u squareds are going to cancel to 0. 1 plus 1 is 2. Well, we started with 1 and we don't want to change it, so let's just multiply by a 1/2 out front. Now this is all equal to 1 if you include the 1/2, so we have the same thing, so we haven't changed the integral. And then let's just go ahead and break this up into two integrals. So the first one will have this 1 plus u squared in the numerator. And for the second one, distribute in the 1/2 to the second integral, and now we have 1 minus u squared over the same denominator. And then here we get the cancellation that we wanted, right? We get the cancellation here, and what we're left with is two easy integrals we can do with the formula. And now we'll just go ahead and integrate on this. Now for this one, I have two different formulas. One, we could write this in terms of tanh inverse of u. And then for this one, this is just going to be our formula for arctans. This is just going to be arctan of u. But for this here, we have an equivalent formula that we can use instead. Maybe just because people prefer natural log. I don't really have a preference, but we can write this as half natural log 1 plus u over 1 minus u. And then all that's left is we just need to back substitute here with our u value. So when we do this, let's multiply the 1/2 together. We're going to have 1/4 natural log 1 plus tan x over 1 minus tan x. And then here we're going to have 1/2 arctan of just tan x. But for this right here, arctan of tan of x, I can actually rewrite that and replace that with just an x. Technically, it's going to be x plus a constant, but we already have a plus c here on the end. So having another constant is not going to change anything. It's just going to get absorbed into here. So for my final solution of this, we have 1/4 natural log 1 plus tan x, 1 minus tan x, plus a half x plus c, and that's it. Okay, there you have it. Good one from Swinbee 2023. Thanks everyone for watching. Have a good day.